In this video, I would like to talk about R squared. In the context of correlation, R squared refers to the proportion of variance that's shared between two variables. In the context of linear regression, R squared refers to the proportion of variance accounted for by the model. Now, what do we mean by variance accounted for in the model? In this example, we look at refractive error as a function of years before and after the onset of myopia. So the variance we're going to account for is refractive error. And if we look at variance, variance is just the standard deviation of refractive error squared. We take out that square root sign and we have variance. Variance for the predicted, for the model is this refractive error equals the constant plus the slope times the x, which is x is years in this case. 0.579 is the slope. So for every year you get a change in myopic years following the child, you get a negative about half diopter. And then you add to that this intercept, and that gives you the predicted value for refractive error on any particular year. And that's this straight line. And if we look at all the points on this line, you get the predicted value. And the standard deviation of the predicted value, because there's variance depending on the year as you go across here. If there was no variance, it'd be a straight line. There's a slope to this line. And so the variability of the predicted line is the standard, or the variance is the standard deviation squared, and that's 1.519. And so the variance of refractive error accounted for by the model is simply the variance of the model divided by the total variance, or 7.59. If we go ahead and do a correlation between init years and refractive error, and then square that, we get 0.759. So R squared is the proportion of variance accounted for by the model. Now, we can look at this another way too. We can look at it in terms of what the model doesn't account for. And those are our residuals. So remember, for each point, we looked at the predicted, or the actual refractive error minus its predicted value. That was a residual. That's how far off the line. So all these points, as they fall off the line, that's the residual. That's the error. That's what the model doesn't account for. This is the additional error factor. And we can do that for each one. Each particular point, we have a prediction, what it actually was, and that's the residual. Now, residual, we're looking at variance. So if you think about our, as in the covariance, it was squared. We have to think squared, going under that standard deviation, x minus mean of x. We then square that difference. These are all the squares of the residuals. And then if we take the average of all those squares, we sum them up and divide it. In this case, I divided by n minus 1. Not sure I really had to do that, but I did. And we get the mean residual. And the residual divided by the total variance is 0.24. So we're not accounting for 24% of the variance. Our residual, all the points falling off this line, account for 24% of refractive error variance. And if we subtract 1 from that value, then the opposite of what we don't account for is what we do account for, and that's 0.759, just like we had up here, the square, which is also the correlation squared. And so that's what we mean when we talk about R squared, and we're accounting for, we're looking at how much the model accounts for variance. This is a very important number to keep track of. It varies from 0 to 1.